Well, a little glitter and a lot of lava. This lamp is still groovy after all these years, right? Well, NASA Ambassador Danielle Jones, aka Casey's NASA Lady, is here showing us how to make a lava lamp. Danielle, welcome back to the show.
Thank you.
Lava lamps were really big when I was in college. You had to have your lava lamp on the shelf.
Right.
I don't know why, but I had one. I just bought it, but we can make our own now, right?
Sure, yeah, you can make your own. Normally, lava lamps are using melted hot wax and water, which technically you could make them at home. I really wouldn't suggest you do that. So this is kind of a really cool experiment. There's a lot of science in it. You could do it with kids, real safe. Okay. And it looks amazing. So what we're going to do is, there's a lot of science going on in this. So I'm going to try and break it.
A lot of science here.
I talk with my hands a lot. Okay. Last time I almost hit you in the face. So first we're going to...
It's not the first time it's happened.
That's fine. First we're going to talk about polarity and density. So what we're going to do is we're going to take a little bit of water, and I've already pre-made one so it would settle a little bit. But you take a little water and you're going to take some oil, whatever the cheapest.
So just vegetable oil?
Yep, canola, vegetable, whatever the cheapest that you can find, and you add it.
Okay.
And then you're going to let it settle.
So obviously,
I'm going to add to this too.
Water and oil don't mix.
Right, for a couple of reasons.
Yeah, why is that?
Water is more dense than oil.
Okay.
That's the first reason. Second of all, they have different polarities. So a really easy way to explain that is kind of like magnets.
Yeah.
If you don't line them up correctly, if the polarity is different, they reject each other.
You're negative and positive,
exactly.
negative.
The electrons,
yeah.
right? And oil has no charge at all, so it's not going to react to anything unless you have an emulsifier, but that's a whole different thing.
It's more sciencey.
Yeah, very, very
right
sciencey. So what you're going to do is you're going to let that settle, and you can add a color. I mean, I don't really. Do you care what color? Okay.
I like pink.
Yeah, let's do pink. Like, I think it might be purple.
Well, I like purple too.
Yeah. Too late. You have to like purple now. So anyway, so you're going to swirl, and let it kind of mix, and this isn't going to do it for us, so we're just going to...
Well, it's kind of pulling it apart a little bit.
Yeah, it takes a while for it to settle down, and then by the time we're done with the segment, it'll settle down and change. Well, anyway, this one's ready. So I'm not bleeding. So what you're going to do then is you're going to take some Alka-Seltzer. Alka-Seltzer is baking powder and aspirin. They're two very reactive things because one's an acid and one's a base, but they can't react because they're pressed so heavily together like this. But when you introduce them to water, they can break up and they can react. Just
effervesce?
Exactly, which is why when you have acid, it works.
Okay.
So what we're going to do is we're going to dump some of this in here.
Is this similar to the same reaction of when you drop Mentos in a Diet Coke bottle?
Yes, same exact thing. When
Excellent.
you break it apart, it can do it.
Okay.
So we're going to let that go like that.
But it's not going to foam all up, but we're still getting the air bubbles, right? Oh, look at it go.
So what you're looking at is that reaction where it's breaking apart and it's releasing carbon dioxide. The carbon dioxide is lifting up. It's a lot lighter than either of these two substances. And it's lifting the water up, and it's going to keep going. And you can actually, once this finishes, you can let it settle. Like this one, see, it's finally mixing.
Yeah.
Let it settle, and you can keep doing it and doing it and doing it.
So putting more of the Alka-Seltzer tabs
exactly.
in there?
Reactivate it over and over and over again.
So all these bubbles in here are caused by the carbon dioxide that's formed from that reaction. Then it comes up, so we're getting a lot of carbon dioxide coming out of the top of that beaker, right?
Just like you were to do the volcano experiment that we all love so much, baking soda and vinegar, an acid and a base, same thing, you're just allowing it to react. And yeah, kids love this. You can have them sit and do it for hours and wait for it to settle.
Now, what if we were to put Alka-Seltzer in that one? Would it start bubbling as well?
Yeah, now this one's settled.
You're getting a little bit more there. Let's see
now we
here.
can do this one. Yeah, now that it's kind of settled, it takes a second. I like to color the water before I do it,
but still you can see it there. It's separating, like you were saying. It's still causing the bubbles.
And you just use enough food coloring to make it pretty dark so you can see it really well. But yeah, you can sit and do that. And any age kids, when you're done, dump down the sink.
And you're good to go.
Easy.
All right. Cool. Well, that's nice. And it's getting some fizz on the top too.
And I say the best ratio is about 75% oil and 25% water.
Okay. Well, now that you have your lava lamp, all you need is your black light and your Pink Floyd, and I think we'll be ready to go. Dark Side of the Moon it is,
There's
right?
an idea. You could use tonic water and use a black light, and it would, I'm serious,
would
it would
tonic
glow.
Water?
Yes, it glows.
All right, get yourself some tonic water. That's next week's experiment. Danielle, we thank you for being here. Belinda, over to you.